Hello everyone, in this video we are going to discuss about action potential in neuron. So action potential in neuron is a brief electrical impulse that allows the neuron to transmit signals. By definition, it is a rapid temporary change in electrical membrane potential of a neuron that travels along the nerve cell membrane, allowing it to transmit a signal over a distance. So the electrical membrane potential changes. These changes in the electrical membrane potential helps in transmission of the signal. So this is called as an action potential. So there are different phases in action potential. The most important thing before this is the resting membrane potential. Inside the neuron, it is always negatively charged compared to the outside. So that's why it is minus 70 millivolt. This is because of the sodium potassium ATPase pump, which pumps the 3 sodium outside and 2 potassium inside. It uses ATPase because it is pumping against the gradient, against the concentration, because generally the sodium are more outside than inside and potassium is more inside than outside. But these are pumping sodium outside and potassium inside. That's why they are using ATP, that's why sodium potassium ATPase. So 3 sodium are going out instead of 2, but 2 potassium only coming inside. So there is more positive charge which is going out, and that's why it is more negative inside, because loss of positive will lead to negative charge only. And also there are potassium leaky channels, which these leak the potassium outside. So these also contribute to negative charge. There is more amount of positive charge, that is potassium is also going outside because of this potassium leaky channels, and 3 sodium is going out through sodium potassium ATPase pump. More amount of positive charge is going outside, that's why there is negative charge inside the neuron. That's why resting membrane potential of the neuron is negative, that is minus 70 millivolt. So there is second thing called as threshold potential. So there is a slow opening of this sodium channels. These causes the sodium channels, voltage gated sodium channels will causes sodium to come inside, because more amount of sodium is there outside, high concentration to low concentration, that's why high voltage to low voltage. So that's why more amount of sodium is coming in because of the sodium channels. So as soon as it reaches, so minus 70 to minus 55, because more amount of positive charge is coming inside, that's why there is less negative charge as it reaches a threshold. So as soon as it reaches minus 55 millivolt, the action potential is triggered. Here there is a voltage gated sodium channels will open, causing the depolarization of the cells. So more amount of sodium is flooding inwards, that's why more amount of positive charge is coming inwards. So it will reach a voltage up to plus 40 millivolt. And next phase is the sodium channels here will close and the potassium channels will open. Sodium channels will close, that's why there is no incoming of this sodium. The potassium voltage gated channels will open. So as per the law, as per the thing, the potassium is more inside than the outside, that's why they will go outside only as per the voltage gated channels. So potassium channels open, so more amount of potassium will flow outward, so more amount of positive charges going outside, that's why it will become more negative. Next is hyperpolarization. Generally these potassium channels will close. Whenever there is long standing opening of this potassium channels, there is more amount of positive charge which is lost, so that's why it will lead to hyperpolarization. And next phase is this potassium channels will close and it will reach a stage called as resting state, that is reaching the resting membrane potential. So there is only sodium potassium ATPase pump will be functioning here along with the potassium leaky channels. So there is a period called as refractory period, that is a neuron cannot fire another action potential during this time. So it can be absolute if there is absolutely no other action potential firing, or a relative refractory period whenever a very strong stimulus can trigger this action potential. So it ensures a one-way signal transmission, that's why refractory period is important. So let us see a gist of this. First, in resting membrane potential, as we already discussed, sodium potassium ATPase pump will be working along with potassium leaky channels. So 3 sodium are going out and 2 potassium are coming in while using this ATP. So this is resting membrane potential minus 70 millivolt. So the sodium channels will open slowly and it will reach a threshold potential minus 55 millivolt, and then starts the action potential triggering, where there is depolarization phase. That is, voltage gated sodium channels will open, causing the sodium to come inside, more amount of positive charge inside the cell, so it will become plus 40 millivolt. Next is repolarization. Here the sodium channels are closed and potassium channels are open. Potassium is more inside than outside, that's why it will go outside. So the potassium channels opening causes more amount of positive charge loss from the inside the neuron, so it will become less positive or more negative. So next phase is hyperpolarization. Here prolonged opening of the potassium channels will cause more amount of positive charge will to go out, so that's why there is more negative charge. Next, as soon as this potassium gated channels are closed, this only sodium potassium ATPase pump will work, 3 sodium outside, 2 potassium inside, that's why it will reach the resting membrane potential minus 70 millivolt. So there are few characteristics of this action potential, that is all or none. That is, once threshold is reached, it will fire fully. It will always fire fully. It is all or none phenomena, unidirectional, moves from axon hillock to the axon terminals only. Next is saltatory conduction. This is seen in myelinated neurons. This action potential jumps from node to node, that is roads of runway, helps in faster conduction. The three things are all or none phenomena, unilateral flow, unidirectional thing, and saltatory conduction. So the 5 phases are resting membrane potential, depolarization, repolarization, hyperpolarization, and here there is a refractory period, and again it will reach the resting state. So these are the important points in the action potential in the neuron and how the electrical signals will transmit in the neuron.